All right, folks, so let's take a look at our notes for today. Does everybody have notes for today in front of you?
Yeah.
Great. Today we are going to learn about logarithms, and we are going to use logarithms to evaluate and also to solve. A logarithm is another way to write an exponential. It's actually defined to be the inverse of an exponential. So the reason we need a logarithm is to solve a problem like 2 to the x equals 128. So a lot of you could either know that answer or guess and check that answer until you got it right. But a logarithm can also give you an answer to something like 2 to the x equals 5, right? So we know that the answer to 2 to the x equals 5 is more than 2, because 2 to the 2 is 4. And we know it's less than 3, because 2 to the 3 is 9. But it'd be very hard to guess and check all of the digits of that answer, but a logarithm can give you that answer. A logarithm is the inverse of an exponential. But before we talk about the logarithm as an inverse, we're going to talk about how you can rewrite an exponential equation as a logarithmic equation. Logarithms look confusing because that's a whole word in your equation. It says log in your equation, but it really works the same as other functions. It's an inverse of an exponential. So here's your exponential equation. Here's your equivalent logarithmic equation. Both a logarithm and an exponential equation have something called a base. So the base of the exponential here is 2, and this is called log base 2. The answer to a logarithm is the exponent. So what we're going to do is we're going to try to use this to rewrite exponential equations as logarithms and then rewrite logarithms as exponentials. All right, so let's see if we can follow this. First thing we have to do is write the word log. Then the base of your logarithm will be the base of your exponential. So it's going to be log base 6. And then this number here is this number over here. Sometimes we use parentheses, sometimes we don't. It's fine either way. And then the answer to your logarithm is your exponent. So I want you to take a moment now and see if you can do the next two here, rewriting your exponentials as logarithms. All right, log base what? 49, right. So the 49 is like a subscript. It's a small number. It's lower than at the rest of the equation, okay? And then we're going to put what number? 7. The 7 is not a subscript. It's like on the normal line. So this is the normal line. This one's a subscript. Equals what number? It is 1/2. Okay. All right, and then the next one, log. Your base is the same as the base of the exponential, so 3, then 81, and then the answer is your exponent. So you could actually solve that one, since that one has x by itself. I'll show you on the calculator, but I don't want you really using the calculator that much because we're going to be doing some in our head. I mean, you can do 3 to the x equals 81 in your head, right? You just multiply 3 until you get to 81, but I'm going to show you on here as well. So I think that the log base is in the math button. Nope, it's not. Okay, I'm not going to show you yet because I forget where it is. I'm going to go ask next door. Okay, it's okay. We know what this is though. 3 to what power gives us 81? 3 to the 1 is 3, 3 to the 2 is 9. What's 3 to the 3? You guys, turn your brains on. Come on. 27. Very good. 3 to the 3 is 27. 3 to the 4 is 81. So this answer is 4. And that's what you would get if I could figure out what buttons to push to get log base in here. But I'll get that for you in a minute. All right. Now we're going to take the logarithm and write it as an exponential. Some of you have worked ahead, which is super. I love it when you guys work ahead. The base of the logarithm is the base of your exponential, so write that number first. The answer to the logarithm is your exponent, and that equals 32. And when all of these things are numbers, like you can tell if you got it right, if it makes sense. 2 to the 5 equals 32. Is that true? 2 times 2 times 2 times 2 times 2, it works. Okay, do the other two while I go check on which buttons to press on this calculator. Okay, so your base is 5. The answer is your exponent. 5 to the 0 equals 1. It is true. Anything to the 0 is 1, right? All right, last one. Base is 3. Exponent is 1. And that gets you 3. What questions do you have about rewriting? Okay, special bases for logs. There are two kinds of logarithms that are special. One of them is log base 10. So I want you guys to think about the number 10 in our number system, 10. And I want you to talk to people in your group about why the number 10 is a special number in our number system. So, 10 is a special number because it is the base of our number system. And so it's called the common log. And log base 10 is just written as log. It doesn't have a base. So when you look on your calculator and you see a button that says log, that's log base 10. If you forget like what base goes with the word log, look above log on your calculator. See how it says 10 to the x? That's a hint, okay? So above log is 10 to the x. That's a hint. That's log base 10. So then you have natural log. Natural log is ln. And if you look on your calculator, ln has an e to the x above it. That's a hint that ln is log base e. So log base e is written as ln. All right, important ideas there. Raise your hand if you weren't listening and you want me to say it again. Raise your hand if your friend wasn't listening and you want me to say it again. Okay, here we go. If you see the word just log without a base on it, it means log base 10. If you see ln, that means log base e. So when I see this here, when I see an exponential and I want to write it as a logarithm, I'm going to start by writing it log base 10 of 1,000 equals 3. But then I'm going to remember, like, mathematicians don't write log base 10. They just write log. So after I've done the steps and I've gotten it the way I like it, then I'm going to change log base 10 to just be log 1,000 and then equals 3. So when you have log base 10, just write it as log. If you see log without a base, you know that's log base 10. All right, let's do the E one. When I want to write this as a log, I'm going to write log base E of root E equals 1/2. So the first thing I did was translate it just like I did in the previous section. But then I remember nobody says log base E. So instead of log base E, I replace it with ln. Log base E is written as ln. ln, that means all of the log base E. So I still need root e equals 1/2. Now when I see logarithms without a base, I know it's log base 10. And some people can just know that in their head. I just like to give myself a little 10 there just to remind myself, oh yeah, that's log base 10. Because then it's easy to apply like what I've learned in the other sections. So the base of my log is 10, that becomes the base of my exponential. My exponent is -2. And then this number goes over here. All right, I'm going to do half of the next one for you and then have you finish it. So here's the half I'm going to do. I'm going to change ln to be log base e, and then 1 equals 0. And now I want you to take this and write it as an exponential. All right, did you write e to the 0 equals 1? Is that right?
Yeah.
Okay, because anything to the 0 equals 1, right? So the base of the log is the base of your exponential. The answer to the log is your exponent. All right, once you have that, turn the paper over. All right, in example 3, we are going to find the exponent. Remember that the answer to the logarithm is the exponent. So when you see a problem like, let's do the last one first. When you see log base 5 of 1/25, you're asking yourself, 5 to what exponent will give you 1/25? You don't have to write those words out every time, but I'm going to write them out to help you process that. 5 to what exponent gives you 1/25. Okay, take a moment to talk that over with your neighbors. It does make sense? Yeah. Good. I like that you're thinking about what makes sense. All right. All right, we said 5. Whoa, that's not 5. 5 raised to the -2. And now we're wondering, is that 1/25? Press your math button, this one right here, and choose fraction.
Wait, which one?
The math button on the left. Choose fraction, and it will change your 0.04 to a fraction. So it's right. Okay. All right, so this answer is -2, because 5 to the 2 gives you 25, and the negative gives you the reciprocal. So try as many of these as you can without your calculator, and then if you want your calculator just to double check, you can do that. We're just trying to find the exponent in each problem. Okay, Tabitha's group, which one do you want to give us? Do you want to give us A or a different one? Okay, what'd you get? So 8 to the 1 equals 8. Do you guys agree? Good. All right, Antonio's group, which one do you want to give us, B or a different one? Which one do you guys want to tell us? So B is 2 to what exponent gives us 16? 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16. That works. Oh, thank you. All right, Taylor's group, what do you guys want to give us? C, D, E? E?
Yeah.
All right, what'd you guys get for E?
3 to the power negative 1.
3 to the negative 1. That would give us the reciprocal. Well done. All right, Ryan's group. Do you guys want to do C or D? C. Okay. So whenever I see log like this, I put a little 10 in here. So you're thinking 10 to what exponent gives you 100? What'd you get? Okay. So your answer would be 2. All right. Raise your hand if you have D. That has seemed to be the hardest one. Who wants to share D with us? I think I heard an answer, but I'm still looking for a hand. I want to know who's sharing with me. Nobody knows? Just not feeling sure? So you can rewrite ln as log base what? Log base e. So I have log base e of e. And so the question is, e raised to what exponent will give me e? It's kind of the same question as this one, right? 8 to what exponent gives me 8? Yeah, the answer is 1, just like somebody did share anonymously before. Nice job. All right. What questions do you have on that before we go on to another way to talk about logarithms? Questions on that? Okay, so logarithms are exponents. A logarithmic expression equals an exponent. Okay, here's another important idea. Logarithms are defined as the inverse to exponentiation. It's a long word, exponentiation. How many syllables is that? Exponentiation. I think 6. It's a pretty good word, huh? All right. Remember that inverse functions undo each other. So when you have a logarithm with base 5 and an exponential with base 5, the log base 5 and the base of the exponential cancel out, and so it would simplify in this case to just 2. You see that? The same thing happens when you have an exponential and the exponent is a logarithm with the same base. So the base is 4, the base is 4, those cancel, giving you just x. Okay? So exponentials and logarithms can cancel each other only if they have the same base. I'm going to write that down. Exponentials and logs cancel each other only if they have the same base. Okay, so I would like you guys to work on this section. You're going to see if you have an exponential and a log with the same base. Actually, let's look at B before we do. In B, we could answer this question like we did before. 5 to what exponent gives 25? And we know that answer. Yeah, very good. It's 2. But another thing we can do is rewrite the 25 so that it has a base of 5. So it could be log base 5, and 25 could become 5 squared. And then we can cancel this out and still get 2. Okay? So, yes, you could take something like B and answer it like we did before. Or you could rewrite it as a number with the same base as the logarithm. They're both choices. So work on this section. All right, so C should be a pretty straightforward one. We had log base 3, 3 to the negative 2. So log base 3 and 3 will cancel, and you just get negative 2. In number E, which has to do with E, some people find it helpful to rewrite that as log base E. You don't have to. If you want to, you can write it as log base E, E squared, and see that these cancel, and you just get 2. But some people, eventually you're gonna realize that ln and e are inverses, and you'll just cancel them right away. So if you get to that point where you don't feel like you need to write log base e, e squared, and you just cancel ln e, that's fine. You can do that. It does become a problem here, though, because we've got this extra thing on the e, which we're not really sure what to do with until we remember that cube root is the same as what exponent?
Or 1/3.
1/3. So now I can write this as ln e to the 1/3. And at that point, you could cross out the ln e if you remember that they're inverses. Or if you want to do one more step, you can write log base e to the 1/3, because ln means log base e. Cancel those out. And then finally, your answer will be 1/3, no matter what point you decide that's true. All right, so this whole row has ln's and e's. And an ln does mean log base e, and that's why it cancels out with the e. But eventually you get to the point where you just see ln and e and you cancel it. And you see, okay, that's just x. You see ln and e, you cancel it, and that's going to be just 5x. All right, in the last row, we had log base 14 of 14, and a lot of you realized we could put what exponent on that 14? 1, yeah, so 14 is the same as 14 to the 1, so then you can cancel this and just write 1. Then I have log, and it doesn't have a base. So if it doesn't have a base, that's base what? Base 10. So remember, when you see log without a base, it means log base 10. So then you can cancel these out and just have 4. This is log base 10 also. And some of you can do this like you did before and just think 10 to what exponent gives you 1 over 100, and that's fine. But you can also rewrite 100. 100 is 10 to the negative what? Negative 2. Then cancel these out and get the final answer of negative 2.
Wait, can you say that again?
Yes.
Oh wait, never mind, I get it.
Okay.
It's a fraction.
Okay. Again, I had log here without a base, so that means log base 10. And 10 is the base of my exponential, so I can cancel those out and just have 3. So remember, the reason I'm canceling is because logarithms and exponentials are inverses of each other. When I write log 10 to the 4, like problem J, log 10 to the 4, remember that I'm not multiplying. Like often you're used to seeing things next to each other, and that means we're multiplying those two things together. We're not multiplying. Logarithm is a completely different function that we're applying to on that 10 to the 4. And we're doing that because a logarithm is an inverse of an exponential. But that's one thing to keep straight in your head, is that we are not multiplying. All right. In example 5, we are going to use logarithms to solve exponential equations. And we will have more lessons that do this more in depth. But today is an introduction. So in order to solve a problem like A, we're going to do a log of both sides. And we want it to cancel out with this 3 here, so it's going to have to be a log base 3. You're going to use a log with a base that matches the base of your exponential. So what I'm going to do on both sides is log base 3. 3 to the x equals,
Wait, I can't please.
nope, better? And then I'm going to do log base 3 on this side as well. So I'm taking the log base 3 of both sides. I'm going to drop my comma because I don't want to accidentally try to put a comma in the calculator. That will mess it all up. The reason we do that is because now that cancels out on the left side the 3, so I just have x. And then on the right side, I can use my calculator to find the answer, and now I know how to tell you how to do it. So I want to make sure everybody has that before I stick the calculator underneath the camera. What we did was we just wrote log base 3 in front of the left side and log base 3 in front of the right side. Okay, so now we need to know how to do this on this calculator instead of Desmos, because this is what we're going to have on the quiz. Log base 3, or log with a base, is under the math menu. So you're going to press your math button over here. And if you use the up arrow, you'll see choice A is log base. Okay? So one more time, I press the math button. The math button's over here under alpha. And then use the up arrow and you'll see log base. That's what you want, so you press enter. I'm going to change the base to 3. And in here, I'm going to put 531,441. Okay? I want to see that you know how to do that in your calculator, and press enter, and then we'll get an answer. All right, so when I press enter, I get 12. I think I saw some of you guys also got 12, which is good. Okay, let's do B. In B, I'm going to do log base what? Lena says 4. Anybody else think we're going to do log base 4 in B?
Yeah.
Yeah, because the base of the exponential is 4. So log base 4, 4 to the x, and then log base 4, 128. And those will cancel because they're both base 4. And then we're going to put this in the calculator. So remember, you're going to press the math button under alpha, go up to A, and then put in the 4, and I think it was 128. Did you guys get 3.5?
Yeah.
Good. Okay. There's more than one thing we could do in C, but we could just do straightforward the same as what we were doing before. What should be the base of our logarithm? What's the base of the exponential? Is the base of the exponential 1 over 100 or is it 1,000? 1 over 100. So we could literally just do log base 1 over 100. Right? So that whatever is the base of your exponential is the base of your logarithm. How does it feel about having a fraction down there? I think it's okay. Let's try it. Okay. Math. Log base 1 over 100. Oh yeah, it's totally fine with that. 1,000. I got negative 1.5. Anybody else get negative 1.5? Good. Okay. All right, I want you guys to do the last one, 2 to the 5, okay? Did you do the last one? Yeah. Okay. Put your pass in. Two is the base, so it should be log base 2, 2 to the x equals log base 2, 5. These are going to cancel out, and you're going to do math, log base 2, 5. And you get a lot of decimal places. I'm going to round it to 2 decimal places, so 2.32. But there were no directions as to how to round it, so I understand if you chose something different. Any questions on that one? Okay, we just have one more section left. And these are actually pretty much review. These are rewrite. And then after you rewrite, if you can simplify further, you do. If you can't simplify further, then you don't. Like, for example, this one is all numbers. After you rewrite it, you'll be done. This one over here has 2 variables, so even when we rewrite it, we won't be able to solve it. But B and D, we should be able to find the value of x. Okay? So rewrite each of these. If it's a logarithm, write it as an exponential. If it's an exponential, rewrite it as a logarithm. I think I wrote these backwards. Okay, thanks. Okay, let's see how you did. In A, the base is 14, the exponent is -2, and that should be 1 over 196. Did you get it? Okay. In B, the base is 2, the exponent is 6, and that is equal to x. And that's something we can solve. What is 2 to the 6? It's 64? 2 to the 6. You are right. All right, and then in C, we're going to rewrite as a log. So it's log base 8, and then A, and then the answer to the log is the exponent. And I can't do that because I have 2 different variables, so I can't solve that. And then the last one, you can solve this by taking the log of both sides, or you can rewrite it. There's 2 choices, okay? Either solve or rewrite, then solve. It's up to you. So you can solve it by taking the log of both sides, or you can rewrite it as a log. So it could be log base 5, 125 equals x. And then you can put that in your calculator and get x equals 3. You might have also known x equals 3 from the beginning, because in the beginning, you just knew the exponent of 3 would give you 125. Either one's fine.